Okay, hello class, and in this one I'm going to be going over lesson 2.05, isotopes and average atomic mass. So let's get started. Noble gases have many uses. Neon and other noble gases are used for colorful signs, and those of you who know me personally might know me well enough to know that I just absolutely go crazy over this picture. Why? Because it's a dragon, and I'm fangirling over dragons. So, an argon laser is one of many types of lasers. There are 3 different types of neon atoms in nature called isotopes.
Isotope.
Atoms of the same element that differ in the number of neutrons in the nucleus. Just a sec. Oops. Okay, so looking at this, we see 10 plus 10 equals 20. Protons plus neutrons equals mass number. Therefore, there are 10 neutrons and 10 protons. 10 plus 11 equals 21. Protons plus neutrons equals mass number. There are 11 neutrons, 10 protons. And 10 plus 12 equals 22. Protons plus neutrons equals mass number. 12 neutrons and 10 protons. Now, simply looking back, we see that the protons number stays the same. There are 10 protons without these 3 examples. But we notice that the neutrons eventually goes up, and it increases by 1 every example. There are 3 examples. These are 3 examples of isotopes in the atom neon. These are 3 examples of neon isotopes. Different atoms have different assortments of isotopes. So looking at this whole entire thing is 22. Those are 22 protons. So we know that this is the element titanium. But the number of neutrons directly varies, 24, 25, 26, 27, 28. Therefore, increasing the number of neutrons while having the number of protons stay the same makes all of these isotopes. See, there's 46 titanium, 47 titanium, 48 titanium, and I'm assuming this is 49, just a typo, and 50 titanium. How they get the little number, the 46, 47, 48, 49, 50, they add the number of protons plus the number of neutrons without each. As for this, all of these are 34. The number of neutrons increases, 40, 42, 43, 44, 46, 48. These are selenium isotopes. 74, 76, 77, 78, 80, and 82. Radioisotopes can be created in laboratories. Oh my gosh, why do I keep doing that? Okay, the mass of an atom is measured in atomic mass units, AMU. Okay, atomic mass unit. The mass of 1/12 of a carbon minus 2 atom. Minus 12, my bad. Not all isotopes are found in the same abundance in nature. Looking at this pie chart, which I'm assuming is what that's called, we can see that 40K, also known as 40 potassium, has an abundance of 0.011%. That is that little red sliver on the pie chart. Looking at 41 potassium, we see that the abundance is 6.73%, represented by the blue slice. That is its abundance in nature, so it is fairly popular, but that is kind of rare. That is kind of uncommon. This would be 39 potassium. The abundance would be 93.25%. This probably would be the most abundant in all nature. You can calculate the average atomic mass of any sample of an element if you know what the isotope data is. Average atomic mass, the weighted average of all the isotopes in a sample of an element, taking into account their different atomic masses and their different abundances in nature. So now I'm assuming they're going to show us an example. Yep. So we have two isotopes, 35 chlorine and 37 chlorine. The percent abundance for 35 would be 75.77. The abundance for 37 would be 24.23. Mass, or AMU, for 35 would be 34.969. And the mass, AMU, for 37 chlorine would be 36.996, or 966. Strategize. If the abundance of 35 chlorine were 100%, then you could find the average abundance simply by multiplying 34.969 by 100%, or 1.00. With more than one isotope, you proceed in a similar way, but then add another term to the equation. Mass chlorine equals abundance 35 times mass 35 plus abundance 37 times mass 37, where A is the abundance of the isotope and M is the atomic mass. Given the information, each isotope has a known atomic mass, and its abundance is expressed as a decimal. Abundance 35 equals 0.7577. All they do is move the decimal over to the left 2 spaces. For mass 35, 30 equals 34.969 AMU. Abundance 37 equals 0.2423. And the mass 37 equals 36.966. Calculate. Replace the appropriate variables with the numbers they represent and perform the calculation, expressing your answer fully. Mass chlorine equals 0.7577 times 34.969 plus 0.2423 times 36.966. Mass chlorine equals 26.496 plus 8.957. Mass chlorine equals 35.4. The average atomic mass of chlorine is 35.453 AMUs. Find the average atomic mass for a sample of potassium. Okay, all the protons are the same, 82. Neutrons, 122, 124, 125, 126, so on and so forth. Okay, abundance 39 equals 0.9326, mass 39 equals 38.9637, abundance 41 equals 0.0673, mass 41 equals 40.0962, abundance 40 equals 0.0001, mass 40 equals 39.964. There are 4 isotopes, so with that in mind, mass potassium equals abundance 39 times mass 39 plus abundance 40 times mass 40 plus abundance 41 times mass 41. This says that the mass of isotope 39 potassium times its abundance added to the mass of isotope 40K times its abundance added to the mass of 207 Pb plus its abundance added to the mass of 41K plus its abundance is equal to the average atomic mass for a given example of lead. Mass potassium equals 0.9326 times 38.9637 plus 0.001 times 39.964 plus 0.0673 times 40.962. Replace the appropriate variables with the numbers they represent. Mk equals 36.338 plus 0.004 plus 2757. Mk equals 39.099. The average atomic mass of lead is 207.22. If you know the atomic mass of each isotope and the relative abundance of each isotope, you can determine the average atomic mass of an element. I'm cutting it close to home here, kids. Okay, collect the given information. I'm not going to try to read all of that. There we go. Strategize. Okay. Mass PB equals A abundance 204, and so on and so forth. This says that the mass of isotope 204 lead times its abundance added to the mass of isotope 206 lead times its abundance added to the mass of 207 lead plus its abundance added to the mass of 208 lead plus its abundance is equal to the average atomic mass of the given sample of lead. Calculate 2.856 plus 49.64 plus 45.74 plus 108.98 0.221 times 206.976 plus 0.524 times 207.977. Replace the appropriate variables with the numbers they represent. Mass lead equals 2.856 plus 49 plus and such. Perform the calculation. Mass lead equals 207.22. The average atomic mass of lead is 207.22. Express your answer fully. Okay. So, the isotope of an atom has the same number of protons but different number of neutrons. Most elements have 2 or more isotopes. An isotope is a different form of the same atom of the element. By definition, any atom of an element has a set number of protons. It is the number of neutrons within the atom that varies. Each isotope has a different atomic mass, and each occurs in nature in a different abundance. Understanding these simple facts can make it possible to calculate the average atomic mass, AMU, of a sample of that element. Looking at this table, we see types of atoms, isotopes, examples, carbon minus 13, and uranium minus 238. These are both negatively charged isotopes, also known as anions. Types of atoms, isotopes, averaging results in average atomic mass. I hope you enjoyed this lesson, and thank you for tuning in. Good luck.